Good evening friends. Today we are going to talk about the cooperative behavior of hemoglobin molecule. Now this hemoglobin molecule is made up of four polypeptide chains, beta 1, beta 2, alpha 1 and alpha 2. Basically we can see this hemoglobin molecule as alpha 1, beta 1 and alpha 2, beta 2 dimer. So now what is practically seen is that when one of the oxygen molecule binds to one of the polypeptide chain, then this oxygen molecule pulls up this heme or iron group upward, and there is change in electrostatic interaction between the two polypeptide chains. Here we can see that this is polypeptide chain 2, this is polypeptide chain 1. So when the oxygen binds to one of the polypeptide, then there is change in interaction, and these two of the polypeptide chains, they move closer to each other. Now, so how do different heme groups they interact with each other? We see these are four heme groups which have lot of distance between them. There is no physical contact with them, but it is practically seen when one of the oxygen molecules it binds to one of the heme group, it increases the affinity of the second heme group to bind to the oxygen molecule. Similarly, when second oxygen bind to this heme group, then it increases the affinity further to bind to this heme group. So because of this change in electrostatic interaction, there is cooperative binding. There is change in surface to surface interaction, and when one of the heme group is oxygenated, one dimer rotates with respect to other dimer. So this leads to cooperative behavior of hemoglobin molecule. When the polypeptide chain doesn't bind to oxygen, it is called deoxygenated form of hemoglobin. And this deoxygenated form of hemoglobin is T state or tense state. And when oxygen binds to this tense state or the deoxygenated hemoglobin, it turns into relaxed state. And to the relaxed state, it is much more easier to bind to the oxygen molecule. So